Hello, welcome everyone to the next case study on the Salinity intrusions in the sheltered estuary of the Terengganu River, Malaysia. Showing to you in the front page here is a river mouth of the Terengganu River, where we have the iconic drawbridge of the Terengganu nearby here, and then further far is the South China Sea, and then as we can see in between of the bridge here, it is the breakwater that right in the river mouth of the Terengganu River, and along the river itself, we have the fisherman boat industry that's going on there, and then this river is quite heavy traffic with the water transportation, especially for the water taxi, fishermen, small boats, and also for the tourist activity. So the Terengganu River estuary is a sheltered estuary, as we can see from this far. So this is the Terengganu River. So this is the river mouth, and further north we have the Terengganu Airport here. And this is the breakwater that I mentioned earlier, and then nearby here this is the drawbridge, and right afterwards, so this is another bridge that crossing the Terengganu River, and right in the middle of the Terengganu River itself, as you can see here, there are several islands that form right in the middle of the river itself. It is because of the sedimentation issue, where the flushing rate is slightly lower, and then because of that, all the sediment traps inside of the river and form the islands rather than the flushing out to the sea and then supply to the beach along the East Terengganu coast. Further upstream, there is the man-made reservoir known as the Kenyir Lake or Kenyir Dam, that located upper part of the Terengganu River upstreams, and it serves as a catchment area for the hydro to generate electricity, which is a hydroelectric, and it's regularly discharge the fresh water throughout the Terengganu River. For this case study, so this is the study area. So basically, this is Peninsular Malaysia, also known as the West Malaysia, and we have on the right side here East Malaysia, Sabah and Sarawak. Right in the middle, we have the South China Sea between. So as we can see that this Terengganu River dominated by the influenced by the South China Sea. And further up detail, what we have in the in the Terengganu River itself, so we have the breakwater on right and left sides, and then the drawbridge somewhere here. In the middle, that we have the islands that form in the middle of the river, and then along the river itself, we have a station 1, 2 is located further close to the sea, followed by 3, 4, 5, 6, 7. So 7 is where we have the stations that junctions with another river, tributary to the Terengganu River, which is the Nerus River. And then further up, we have station 8, 9, 10, 11, and most further upstream is station 12 here. So this study, basically they are using the hydrodynamic model and advection dispersions model, which is coming from the Mike 21 by DHI. So as we can see here, this is the domain they created for the simulation. So some part of the area is covered by the sea, and then they have a nested mesh nearby the river mouth, and then they have another mesh inside the river itself. So there are three open boundary here. So we have the north boundary, offshore boundary, and southern boundary right here. And all these fit by the forcing, which is normally water level as their boundary forcing. And then inside the river itself, as we can see, this is the bathymetry, basically bathymetry of the Terengganu River flowing here, and then this is the Nerus River that feeds into the Terengganu River is also right in the middle. In the grey side, this is the islands that mentioned earlier, and as we can see that nearby the estuary itself, we have slightly shallow area, and then right in the middle of the islands we have a slightly high water depth, and then it's gradually uh, e- um, and then some other parts here nearby the stations 11, slightly high water depth here. So the model have the validations where they were using three parameters, which are the first one is current speed, second one is current directions, and then the last part is the water level itself. And as we can see here, the black line indicates the measured data, field observation data. Meanwhile, for the red line here is the simulated coming from the simulations output. And in general, as we can see that the model is quite good, which is quite aligned with the with the measured data, and then they are quite can capture the situations quite well, and therefore the model is acceptable to go for further analysis. So some of the results from this case study, they are looking for in two different tidal cycle, because after all it is an estuary, and as we all know, estuary is normally dominated by the tidal influence. And the flooding tides and the ebbing tides, so the flooding tide where we have lots of sea waters coming into rushing into the river. As we can see that we see inwards flow at the river mouth here, and meanwhile at the sea part near shore area we see southwards current directions. And from this one shows to us the significance with height, where it indicates during the flood tides we could observe the higher significance with height compared to during the ebb tides. Ebb tides is where we have the outflow from the river towards the sea, and the net flow near shore here is moving northwards. So mostly the current move northwards directions during the ebb tides. This study also look for the longitudinal distribution of the salinity institution, where they do the cross sections here. So as we can see the first figure, so other than looking at the tidal influence, this study also observe the monsoon season, where Terengganu itself largely dominated by the monsoon season, where we have the southwest monsoon season, which is also known as a dry season, and also northeast monsoon season, which are also known as a wet season. And normally it's dominate in the peak is in December for the wet season or northeast monsoon season, and July, which is known as a dry season or southwest monsoon season. So the cross sections that we have here is that on the right side here is the sea directions, and then towards the left side from here to here, so they are moving further upstream. So where we have the at this line here, so this is the join to the Sungai Nerus, which is the Nerus River, and this is where we have the junctions to the Nerus River. As we can see that during the wet season, we could observe that higher water depth compared to the dry season, and again is of course contributed by the heavy rainfall, more discharge coming in into the river, so thus it creates a higher water depth in the river itself. And meanwhile, for the salinity certification means that we try to see the mixing of the salinity itself. It either how much the salt water coming into the river system, and normally based on the density, the salt water we settle at the bottom, and fresh water will be flowing at the surface, the middle of surface part of the water column. And again, on the right side, it is the sea, South China Sea, which is the one that near to close to the estuaries, the breakwater itself. And then further to the left, they are moving more towards the upstreams. And as we can see that, so the square line here shows during the wet season. So this one is wet season, and the other one is this is the dry season. So as we can see that during the wet season, the salinity is quite closer to the salinity is only able to travel the salinity, the salt water that's coming from the South China Sea, are not able to travel further to the upstreams compared to during the dry season, where we could still observe the salinity value further far towards inland compared to the wet season itself. This might be due to the more freshwater inputs coming from the river for the upstreams. Thus, they have further force to push the salt water coming into the river. Meanwhile, during the dry seasons, we have a less precipitation, less rainfall, and then we expect less discharge coming from the river, and it give benefits for the seawater so that they can travel further up into the river system. Right, moving on. So this is where they're looking for the salinity profile. So basically, because of there are so many factors that influence the salinity intrusions in the Terengganu River itself. One is the river flow itself, which will affects by the any constructions that happens along the river itself. How many bridges that are being built along the river, because when we have more bridge, then we assume that it will reduce slightly reduce the river flow, and then with the lower river flow means we could expect um, more salt water coming into the river, because we have a slightly slow flow from the river itself. So more stronger current flow coming from the sea. So this salt water could travel further inland into the river system. And then another one is because of the dam itself, the Kenya Dam itself, where of course it will put some control on the river flow and river discharge, and it will affect what we have in the river mouth. And because of that, they try to make a comparisons here, what we have during the high water level and low water level, and the one before and after of the dam constructions. And as we can see here, the trend, the pattern is quite similar. And then the previous the dot is the measured data, where we could see the measured data is quite aligned with the simulated data, and then they still stay within the same range. And as we can see that the model are able to represent the sort dispersions quite well in this model. And as we can see that during the high tide, the salinity level of the river mouth was less, right, when we have the high water level. So less salinity observed in the river itself. Meanwhile, during the low water level, there are almost zero salts content in the longitudinal water column, where the entire estuary behave almost like like a river. And this can be explained by the huge volume of the freshwater discharge from the upstream. So um, during the low water, so we do expect that more salt water coming in, but it is not happening based on this study. That's because of the huge volume freshwater discharge coming from the Kenya Dam itself. So during the low water, the dam play important roles to put control for the salt intrusion in the Terengganu River, where they have their discharge, and therefore it kind of push the salt water so that they couldn't able to get into the river system. And this one is a comparison between before and after the dam constructions. So this is the one that we have before. The dash line is before the dam construction, which is from 1971 to 1975, and the solid line here shows the after the dam constructions, which is the data consists from 2007 until 2011. And as we can see that so the data basically in average of the months, because this study would like to observe on the seasonal difference or seasonal change. During the August is a southwest monsoon, December during the northeast monsoon. And as we can see that before the dam construction, we have higher much more freshwater flow as average in the Terengganu River, compared after to the dam constructions is slightly lower. And this is another reasons why they construct the Kenyir Dam in the further upstream of the Terengganu River, because they try to protect the river mouth, the towns, city that located along the Terengganu River itself. And it is reported that before the Kenyir Dam constructed, the big flood is always frequently happens along the Terengganu River, um, especially during the northeast monsoon seasons. And other than that, the study also observed comparison the freshwater discharge related to the salinity distribution. So basically, they tried looking for if you have much more of the freshwater discharge, so how much the salt water that we get inside of the river or inside of the estuary itself. And as we can see here that the dash line shows the discharge regressions. And then so the solid small dash line here, this is the pump house, and how much salt reading that we can get from the pump house nearby the junctions of the Nerus River, if you could still remember on that. And as we can see here that when we have further more discharge, and we could see that the slightly lower reduced in terms of the salinity value. So it shows that the Kenyir Dam quite play important roles to put control of the salt intrusion situations here, where normally especially during the dry season, where we receive less rain in the area, and we expect like more salts coming into the river. But by having the dam further up, we can put a control on the discharge, and then release more water into the river, so that it can push away further, and then it could avoid the salt intrusions into the river during these periods. As a conclusion, CA defined that the water discharge was the predominant control rather than the tidals and also the water level on the salinity intrusions in the Terengganu River. However, it should also be noted that the humans' interference, humans' activities such as the freshwater extractions that's along the Terengganu River, and also sand dragging activities that might increase the salinity intrusions land to intrude further inland. So this study recommends that these two activities further investigations, and then perhaps they need to be put into some control so that it can avoid critical salt intrusions into the Terengganu River. Right. This case study, if you are interested to observe more, these two papers have been published regarding the topic, which is prediction of the salt intrusion in sheltered estuary of Terengganu River using one-dimensional empirical intrusion model, and the other one is modeling the influence river flow and saltwater intrusions in the Terengganu estuary, Malaysia. So until that, thank you everyone.